Okay, this is activity 5 in lab 5, and the problem that's given is something from a previous year's midterm, maybe in a different course, I'm not sure. But anyway, the situation is this. It says here's the geometry, the inside hole is clamped, the entire inside face is clamped, and this whole structure is subjected to an acceleration in this direction of 400 inch per second square. Use as many planes of symmetry, use the most appropriate element. At this stage, the only element that you know how to use and is appropriate is a solid element, not beam elements. And as far as the symmetry goes, I want you to think about this thing. This has only two planes of symmetry. In other words, you cut it vertically and you cut it horizontally. And so basically, we are dealing with 1/4 of the geometry. Okay. Now, let's go ahead and make it. As I said in the previous cases, you can either make the whole thing and start cutting it, or you can make a quarter of it as you see fit, if that's what you want to do. So we start with a part file. Okay, immediately save it, file, save management, just like you have to do it on the test in the appropriate folder. There is a folder called Lab 5 Activity 5. So anything that I do for this problem goes in there. And on that vertical plane, I will sketch something that looks like this. I mean, you can always go and clean these up, but don't think about it too much because you can always go clean it up. So let me see. Now, how about, actually, let me do the following. Uh, Let me see, for example, what's the best way of doing it? I can make a circle. I can make a, yeah, I can make a two concentric circles and then draw a rectangle and add them together. So let's see, circle, circle, circle. One like that, that's the inside one. Another one like this. Ah, try it again, like so. Yeah, okay. Now we draw a rectangle, perhaps like this. And we're gonna clean it up. Well, let me close this, by the way. You want to do it some other way, be my guest, no problem. Use a quick trim to clean this up. So I'm going to get rid of this. I'm going to get rid of that and that. Okay, let's put some dimensions here. From here to here is 4. So from here to here, it is 4. Okay, the inside radius of this is 1. Make it 1. And this outside radius is 2. And I think what you see there is this, except this height should be 0.5. This height should be 0.5. There we are. Exit, pad it by the entire, okay, pad it by the entire amount, which is 1 inch. You cannot use symmetry by taking half of that thing. It's just wrong, simple as that. Think about it, it's wrong. Good, so let's apply material properties on it. Metal, steel, on that part. Okay, that's pretty much it. So we're going to go to analysis and simulation, generative structure analysis. Let's put our planes of symmetries in different places. So surface sliders, we cut it here, and we know this is a plane of symmetry because we cut it. I put it both in the same constraints. Oops. Wait a minute, what do I do here? Cancel. Did I have it here? Restraint. Yeah, right here. Two of them. Good, good. Now, the inside of this thing is clamped. That's what you're told. And one thing I forgot to do, it says that use local mesh refinement around the hole. So let's do that now. This is local mesh refinement over here. Yeah, if you look at your mesh, you see that is exactly what the kind of thing that you want. So find your mesh in this area. You can see that right there. All right, good, good. So deactivate this plot. Deactivate this plot. And the load is actually acceleration direction x. So here's the acceleration, linear acceleration. It's a body force. It doesn't matter what you pick. It's going to put it on the entire object. The direction should be in the direction x. Should be 0. The direction x, 400 inch per second squared. That's almost a g, something like that. Okay, very good. There we are. So it's accelerated that way. Now notice that, think about it, when it accelerates this way, actually this guy is going to bend in the opposite direction. It's bent like that. Better. Otherwise you do something wrong. Okay, so let me save the analysis. 5, save management, the analysis, save as that folder, but this is the wrong folder. You go up to activity 5. Okay, good, good. And run it. This warning message because maybe my installation, I get this thing. It says rotation is not a 3D degree of freedom, basically. That's fine. I know that. I know that. Okay. So let's look at the motion. So this is going to bend backwards. It should. Oh, wait. Hang in there. Why don't I go forward? The acceleration was in the positive direction. I don't like that. Uh, oh, okay. I see what's going on here. So yeah, I guess obviously for this problem it doesn't matter whether it goes forward or backward. It's going to be exactly behaving the same way. But let me see that. The reason I said it's going to go backward is that is let's say that you were actually sitting in a car and the car was accelerating like that. Your acceleration is towards the front because you're going with the car, but you feel that you're going to go backward. Okay, you feel that you're going to go backward because your body, your mass, is going to show resistance to that. So this is okay, except that if this uh, when you're sitting in the car, you're accelerating forward. Okay, uh, your body will resist that and it presses you against the seat. So that's okay. There's no problem here. That's all right. Yeah. Yes. Okay, let's look at the deflections. It's just that I don't like the way it comes out, but that's a reality. If these points are accelerated forward, of course they're going to go to the front. They're going to go in the positive x direction. There's no doubt about it because they're being accelerated that way. The negative reaction force, the negative inertia force is actually what you feel when you're sitting in the car and the car accelerates forward. You're just pressing against the seat. Okay, so that's pretty much it. If you look at the von Mises stress, needless to say that assuming that this is a good mesh, I mean, remember, it's so easy to generate good-looking garbage. You really have to do a mesh conversion study, and these are totally useless. Not wrong. It's just that it's 1 inch thick piece of steel, and you're giving it acceleration of g's, just like dropping it, for example. So what do you expect? Nothing is going to happen. These are so such low stresses that nothing is going to happen. They're correct, but the stress, the acceleration is so low and this is so massive that basically you don't get much deformation in it. So that takes care of this last last activity. Good luck on your test on the 11th. Okay.